Ladies and gentlemen, it's an honor and it's a pleasure to be here today. I want to especially thank Xenoac Japan for facilitating the hotspot so that I can have web contact, because this is a Prezi file that is on the web and you will be provided with a link that you can open and look at this presentation if you want to again. Prediction models for large data sets and One Health, I think, deserve our attention because our lives are increasingly guided or influenced by decision-making systems that are derived from statistical learning systems, artificial intelligence, big data, and all the consequences of that. And the controversy, anxiety, the panic about this, what might be the consequences and impacts on our lives, stem from the fact that you can control the information flow that is provided to you based on your preferences for browsing the web, for looking into news and fake news, you know the discussions about that. And actually what people who are really insider in this artificial intelligence realm say is, it's not the fact that AI is present that is the scary thing, it's the fact that you can exert control over what people think and vote for what they buy and what they the way they live like. That is the kind of problem. And I will try to illustrate that discussion a little bit. You will have a reference list at the end as well. And I strongly believe that out there's a huge degree of what I call cyber talent. Those are the young people and older people who are currently programming prediction models based on large and very large data sets. Those are young people who share freeware on the internet. They work under great time pressure. They sometimes have to stay awake for hours on end. They consume caffeine without end. And this has psychological and mental consequences, as well as the way that they have been brought up in the digital era, where you communicate through text messages and WhatsApp, you kill your enemy in video games, and these people are creating a reality that influences our decisions. And I think cyber talent needs and urgently needs cyber health. And cyber health relates not only to the individuals involved, the animals, plants, and the environment, but the algorithms that are used for generating AI decision-making systems. They are in great need of a One Health approach and of a healthy approach towards ethics, philosophy, legal systems, and scrutiny from experts such as yourself. And that's why today I take the time to kind of drive us through a few items. When I started preparing for this talk in March, I had an idea what it would be like, and it actually had to change together with the rapidly changing field of AI and large data thoughts. And just yesterday I discovered another paper that I think you should be aware of. So at the end I have a list of 3 articles that I would really recommend for you to have a look at, because it's worthwhile. It's worthwhile our time to become informed messengers between what the cyber community is thinking and doing and what clinical experts in the bovine and ruminant realm can contribute to these models in order to make them more decisive and more informative. So I create this term Cyber One Health that includes coding and algorithms that are optimized not only for statistical accuracy of prediction, but models that are co-optimized for compassion, kindness, fairness, purpose, economics, and everything together in what I call a parameter landscape. So you will see these terms coming back. And thank you for getting up this early and being here. Models, as I call these statistical learning models, they come in many shapes. We can have models for parameter estimation, where we say a risk factor is 2 times more associated with health or disease. And, or we can make prediction models, where we have a set of risk factors, potential risk factors, or what is called features, to predict whether there's a healthy or disease outcome, whether there's more or less milk production, reproduction, and so forth. So parameter estimation versus prediction models. And predictions depend very much on the data quality. This is where we come in. Data quality is very much depending on biases that we have while we are diagnosing something, a condition, while we are thinking about something, leaving out other features. It's, for example, known that many of the human databases, medical databases, they have a scarcity of information about colored women. So drawing inferences from those databases about colored women is almost impossible or strangely biased by the missingness of this type of information. So having a scrutiny and having an overview as to what is necessary to have a responsible reality, what is called a grand truth or ground truth, can be part of our responsibility and contribution to making these data sets. So data quality, bias, missingness of data sets, and the features or the potential risk factors associated with our predictions, those are crucial features that need thorough work and investigation. Most of the prediction algorithms I'm going to be talking about are one way or the other derived from or composed of these linear associations, where you have a variable x, which is our feature or potential risk factor, and it's multiplied by some parameter estimate and corrected for a fact that our regression line could be above or below our origin of the graph, to make a prediction of a health or disease condition y. And either it is just this as a logistic regression with multiple variables, or it is multiple of these lines that are being fitted. But the principle is always, or is very often the same. You have a feature that you chose, for example, through data mining out of a multitude of SNPs, of OTUs, of omics qualities, of production parameters. You have this X, and you multiply it by a parameter to make a prediction about a condition. So artificial intelligence or machine learning are buzzwords, and they are almost obtaining kind of a judgment, as if this is something to be seen critical. So there are alternative terms like automated cognition, statistical learning mechanisms. They can be supervised or unsupervised. You hear about deep learning that came like into vogue or more into the conscience of people involved in 2006 and onwards. Optical character recognition, this is the OCR that recognizes handwriting or printed text automatically. Voice recognition and computer vision models. And I'm going to try to give you a few examples of these things. So this all belongs together. From here, examples for machine learning that are supervised or unsupervised, so-called classifiers. That's your health or disease outcome, a yes-no type of outcome that can be binary or it can be multinomial, could be a time series. Classifiers for OTUs associated with health or disease, as an example, SNPs, gene expression, the entire omics realm of data sets, time series audio files, so think about speech recognition, computer vision, the optical character recognition, printed text, and then another dimension to this handwritten text. It's very difficult to automatically recognize that. And the limitations of these classifiers for recognizing any of these features result in responsibilities about the so-called quality of the labels. What is disease and what is health? I think our definition of disease and health is going to undergo changes, because disease is not like a one-time stop and stage. There's susceptibility and gradation of disease that will be described. And defining the labels of health and disease, and this is the so-called ground or grand truth, and then through data mining, for example, finding predictors for that grand truth, that is one of the kind of bottlenecks for generating AI models today. But you are all clinicians, you're all experts, you have categories and scores about clinical conditions in your heads, and please keep that so, because we are part of the expertise that is able to label what is reality rather than having someone else doing it for us. And this is what is happening right now. There's a big disconnect between what the cyber informaticians are doing in terms of labeling what is reality and truth, compared to what agriculturally oriented clinicians and experts are thinking is necessary in terms of grand truth and labeling. It's a big disconnect, and there are jobs to be found to be the messenger and informed messenger, critical consumers of this type of dilemma. This is where we come in. I'm convinced that you can teach a veterinarian to do anything, an agricultural engineer as well. If you're motivated to apply AI models today, somebody if somebody like me can teach you to do this within a couple of hours, you can go take this to the next level because you are the next generation. I'm looking at my colleagues here in the first rows. You are the next generation. We need you to take this into a reality that is feasible and controllable, overseeable for the next generations. There's nothing to be scared of. There are huge opportunities. I want to show you a few examples. So I want to show you a machine learning example using what is called full model selection. I'm going to give you an example for a binary classifier, think logistic regression of health and disease. I'm going to give you an example for image classification using a single shot detection mechanism. And that's an example where somebody else programmed the grand truth and I applied it to my own video. And you will see what the limitations are. And this is where all the prospects are for improving this type of models. And then another example from the voice recognition realm using Google Translate and what the limitations are when things are out of context. So full model selection for poor metabolic adaptation syndrome, which is like an adaptation to negative energy balance of a cow right after parturition. And some of these cows don't react in a good way to this negative energy balance. We call this poor metabolic adaptation syndrome. I gave a talk about this yesterday. And then we are trying to optimize prediction models and their performance using what is called regression trees. Everybody can make correct prediction models, and there are many choices to be made as to which subsets of data are used, how we transform the data, whether we do use principal component analysis or not, whether we use other axes and compositions of data. And here's an example of a regression tree based on 790 observations of cows that are undergoing this or not poor metabolic adaptation syndrome. And with all the choices we had, we computed a total of 651 models. All of these models are correct. All of these models will generate predictions as to whether the blood NEFA levels of these cows are above our limit value or not. So they will, when grouped into the choices that we made, they will generate accuracy for prediction. But you can tell for each data set actually that you might have in your drawers, the accuracy might vary depending on the choices that you make. And there are no good kind of standard operating procedures to make the best choice. So we are promoting regression tree analysis to make the best choice for the optimized accuracy in this branch here, would be your optimized model approach to this particular data set, to make the best recommendation as to this is your best model of choice given the data set that you have. And computer capacities are such that you can run 651 models times all the observations within a couple of days, generate the tree. And one thing I want to draw your attention to is this tree is optimizing statistical accuracy of prediction, a single parameter. It could be optimizing area under the curve, predictive value positive or negative, but it's always a single parameter. And we would like to expand this tree into like a forest so that we have multiple parameters of optimization at the same time, prioritizing maybe some of these parameters. But this is where prediction models could go from being optimized for statistical accuracy or for killing your enemy in a video game, winning the chess game and so forth, from a single parameter into a multiple parameter landscape. And think about multiple parameters as that compassion, kindness, this humane aspect of prediction models. Yeah, so instead of a single parameter, we want to have multiple parameters. And regression trees, multinomial regression trees are able to accommodate that. And this is me in my winterly disguise on a Wisconsin dairy farm, and one day these 5 cows paraded in front of me, and I submitted this video to an existing SSD model that will tell you in a second who's cow and who's person. So these frames are now recognizing the shape of a person and cows, and it happens to be that the last cow in that row is lame. These models are not able to tell me whether there's a lame cow or not. It only has the labels person and cow. And if you are very observant, then you will see that at some point, in about 2% of the cases, this person was labeled as a cow because there was the shape of a cow's head just behind me. And since it only looks at the circumference of a shape, it will mistake me for a cow. And the same for these stanchions here. There was at the end, there were like 2 or 3 frames, a big frame, and it was labeled as a train. Because these models are trained this way, once you have very regular intervals of certain stanchions or windows, that's a train. So there is error always in these predictions. You always have to keep in mind that if you want to try to assert like an individual frame to a label, there might be an error happening. And in this model, it's about 2% error, but there's always an error. So if you want to pick out a single face in 50,000 people, and 2 people look a little alike, you might mistake Mario for the one person wanted in the world. And he will have trouble for the rest of his life because he looks like someone else. You see what I mean? There's always error, there's always uncertainty, and we have to be aware about this. We have to keep teaching people that, although there's a labeled person, I might be an alien or something like that. Always be aware of the uncertainty around these models. Another example, this time for text and voice recognition, would be Google Translate. And you will probably have used Google Translate while you were here in Japan. For example, the 2 kanji signs for cow and milk are these 2 signs. If I write this in handwriting, Google Translate will not recognize it because it's very wobbly. And there's just too much error, too much bias in this type of my handwriting. If a native let's say, Japanese speaker who's well trained for writing kanji writes this down, Google Translate will immediately recognize it. I think it is part of the culture to have such good handwriting that anybody can recognize your letter with beauty to them. And there's another feature to this. Right now, this is perfectly square. If you look at this milk carton-like house, you could recognize these 2 signs here that represent the same thing, cow, milk. But since there's a certain skewedness to this in the perspective of this house, actually Google Translate will not recognize this as cow milk anymore. So what is obvious to the human eye with my expertise of reading is not as obvious anymore within the parameters of tolerance of such an AI system. And we have to be always aware of this. As soon as there is skewedness, if I turn my profile from that face recognition mechanism, I will not be recognized anymore. There are mechanisms to compensate for that, for example, by what is called transfer learning. So instead of having one picture of myself in profile, the system is going to distort me and generate more pictures of myself until my face is centered and a face recognition model can recognize me in the end. But slight distortions like this tiny bit make that Google Translate cannot recognize you anymore. And this kind of continues. These are the hiragana signs for ushi. I hope I'm pronouncing this all right, for cow. If I pronounce ushi, Google Translate for the voice recognition might not recognize it. And this happens more often. If a word is out of context, for example, if I say, if I'm trying to translate Japanese into English by just providing Dörte Döpfer, actually, and this happened, Google Translate thought this was the YouTube duck song. It did not recognize that this was a name. On the other hand, if I gave it a context and I said, my name is Dörte, then the Japanese voice recognition realized this is something that it needs to translate in the sounds, dore-te-su, and there are hiragana sounds that will be adequate to represent this in Japanese. Yeah, so experiences with words out of context with these AI models and translate that into data out of context will generate problems, will generate prediction errors. And this is a fact, and this will keep being this way. This is nothing new. It's part of the uncertainty of these prediction models. Yeah, so there's error everywhere, which is a good thing. So how do data scientists and AI and machine learning evolve today? And I have to emphasize, I don't give you a complete picture of anything. These are just topics that I've ran across. For example, my blog is my castle. If you want to be present in the current community of the AI sharing community, you better write a blog, or you follow blogs, you should be commenting on blogs, and there's something we can do with everyday language. Think about how our cyber talented young people are brought up. Sometimes they don't know quite how to write blogs, and that's the same for other age groups for sure. So writing and cultivating a certain amount of scientific writing skills is a good thing. But then on the other hand side, if I want to teach a certain age group, I have to address them and pick them up at the level and at the point where they communicate. I have to be able to use text messaging, WhatsApp, Discord, and all those things. I have to try to teach them where they want to be taught. My students don't want to be lecturers anymore. They are annoyed if I start a 45-minute lecture. You're being very patient. They want to have short YouTube sequences of information about the data coding I want to teach them. They want me to be there at the moment when they need that information. They don't want lectures anymore. So we have to definitely change our teaching styles. Think about Kaggle.com. Since 2010, there are competitions on the web where Kaggle provides data sets and data access. Access to relevant data is very important if you want to develop relevant prediction models. Kaggle.com has a collection of data sets that are famous for having triggered big discussions about how to do image recognition, voice recognition, language recognition, all these machine learning mechanisms. Freeware has evolved. Think about Python, R, C+, and so forth. And there's a community with a spirit of sharing. There's a democratization of artificial intelligence ongoing. At the same time as what is ongoing is the gold rush of AI. Who is making money right now with AI are big companies and corporations and zillions of little startups that are either being swallowed by the big corporations, or they develop a niche, and all of the ones that are successful are the ones that communicate well, are scalable to big and large applicable type of decision-making systems, and it is going to be seen as to who survives in this race in the long run. It's really called the gold rush of AI. And similar to the gold rush in ancient times, the ones who are making the most money are the ones who provide the shovels and the wheelbarrows and all the instruments needed, the computer capacity needed, the coding platforms needed for making AI models. The sharing within this community is really amazing, and they share not only their codes and data and logs in order to reproduce their results. They make little modules to teach each other. And very often among the teachings about the code and AI modeling, prediction models, what is provided is kind of general wisdom about how to really lead a life within the AI world. Yeah, so there's a lot of soft messages in between, which I find interesting. So the computing capacity evolved around the gaming industry, the needs of the video gamers. They had a big need of the graphical processing units, the GPUs. So today, when we think about the trade conflicts between countries that are ongoing, it's not so much the soybeans that will be in the future the limiting factors. If today the GPUs of the North American industries were limited for export, then other countries and economies would suffer considerably because they cannot evolve their AI mechanisms. And which are the countries that are currently very much involved in developing AI models? That's China, that's the US, Germany, Japan, France, and the UK. And they're saying, or China has the declared intention to be the world leader in AI by 2030. And it is expected that like trillions of dollars will be gained in value through the AI industry and services within the next 10 years. Huge investments are being made. And it is said even if Europe catches up with the AI and digitalization in development, they might be providing the workforce that then is absorbed by the US and China. So where the competition goes, nobody really knows yet. The cryptocurrency hype right now is in competition with the gaming industry and the AI people. because cryptocurrency needs these very repetitive mechanisms of running matrices, just like the gamers need when they have their figurines tumbling over the screen. So there's a big actual conflict going on where the gamers want to assemble their own PCs for gaming, but all the GPUs are needed for AI development. Yeah, so the price for these GPUs has quadrupled within the past few years. So there are economies evolving that were never predicted. Then there's the data flood, and who has access to these data? If Google today provides platforms and indefinite storage capacity, then basically you're providing databases that big corporations will use, whether you want it or not, for their AI developments. Yeah, so there's like a dual purpose for providing all that storage space. And then a lot of AI prediction models are driven by marketing, retail preferences, and stock brokerage. A lot of economy is relying on this. So how do people train for data science, artificial intelligence, and machine learning? We have to get used to the idea that the experts of today and in the very near futures are not the ones that have an academic degree. Anyone can take a $10 course, or maybe 4 of them, and become an expert. 4 times $10, I can afford that. Probably my 12-year-old can, I have a 16-year-old, but she can afford that. Yeah? So, and the readiness to learn these things is very much developed out there. Code development comes from these remote experts. There's nobody testing them. There's nobody kind of examining them. Nobody knows and scrutinizes how they develop healthy algorithms or not. And health in the sense of, are they still humane? Are they still good-willing for one health in this sense? There are the blogging world, and I'm taking blogging now as a very generalized term, wherever you can deposit text, and this goes for the repositories such as GitHub or Biconductor, where you can deposit your text and your code at the same time and share it through these pipelines. Web courses, if you go to udemy.com, Coursera, YouTube, and suddenly there's a link to the darknet. This is where my IT department said, like, do you really want to go there? Isn't there enough to be learned outside of the darknet? But the next person who might hit that link might not have this hesitation. And there's no scrutiny, there's no, as you know, there are no legal restrictions with regards to the darknet, or not as many as we would wish for. So this is how people train, and the training is really going fast. When I started, again, preparing for this talk, making your own computer vision model was still kind of a specialty. But then came June, July, and Google ML was launched. Today, you can take your labeled pictures and video, I think pictures for now, upload it to Google ML, and for $21 an hour, Google ML will find the best possible model that will make that person-cow distinction, or any distinction that you are looking for with the labels in your pictures. You can do this within a couple of hours, without knowing anything about AI, other than how to upload, how to create an account and upload your data. What are the consequences of that? This Google ML service right now is so crowded that you have waiting lists until you can really upload and get your data running. So it's very popular. Therefore, I still pledge for our cyber talent needs and urgently needs cyber health. Think about these young people, around 20, they probably start an academic degree, but in between the time holes that they have, they try to train themselves urgently about artificial intelligence and these models. They go into what is called polyphasic sleeping patterns. So they sleep for 4 hours, then they work for 6.5. They sleep for 20 minutes, 6.5 hours of work, and another 20 minutes of napping. And they do this on a long-term basis. And these are the people who are producing pre-trained models, labeling reality for us. A big commodity that is emerging right now is pre-trained models. The computer capacity needed to train your own model from scratch is huge, but people are producing like prefabricated models that have a reality programmed into them. And that's very often done by people under a big duress, and they have to deliver, and they will deliver. right? And we are assuming that have the best of intentions. But in the long term, this type of reality labeling will determine as to whether I am worthy of getting this job, of getting this insurance, this loan, where I go, and how I am detected. So there are consequences for that, which is why I think there should be increasing communication and cyber health concepts for this community of people. So choices for coding platforms, choices for performance parameters into performance landscapes are crucial. If you think about coding for deep learning, in 2012, Google released TensorFlow, which has become one of the major platforms for people to develop and code for deep learning models. That's the computer vision, language detection, so forth. And then 2013, PyTorch came out. That's the Facebook version of these coding platforms. And people train themselves, they share codes, they make pipelines. I can download them and use them, learn to use them. And then there are the like Amazon Web Services or the Google Cloud Programming Services. That's where Google ML can be found. Remember that automated black box type of system that will generate a computer vision model. And these services are available against payment. And what the sharing community did was release what is called AutoCarers. So you can do the same thing as Google ML for free. Yeah, so you always see these moves into commercialization, and then there's a community that says, no, but this should be freely available because we are talking about democratization of AI. Choices of performance parameters. Remember this regression tree optimized for a single accuracy parameter. Well, other performance parameters could be statistical. They could be socially acceptable data sets, socially acceptable performance parameters, genetic, economic, compassionate. They could be derived from kindness if we were able to measure them. So sociology right now is very much engaged in making measurements possible for compassion and kindness and fairness. Coding ethics, and it could be an aesthetic performance parameter. What is beauty in our world of AI? Totally undetermined. We are talking, or Henry Kissinger released a press release in The Atlantic saying actually our era of enlightenment is coming to an end. Enlightenment meaning knowledge-based decision-making processes. While these big data sets, they don't have a hypothesis anymore. It's like a grazing for patterns within big data sets. And this might end our culture of knowledge-based decision-making, as much as we like it or not, and whether we like it or not. But it's not that we don't have a choice. We can get involved and influence this type of development. So performance landscapes. Don't optimize AI models for a single parameter. Take multiple parameters. Don't allow, or the good AI models, they should not control what you are fed in terms of information or what you think. They should give you the choice of telling you, okay, we are providing this information based on these parameters that we know about you, your location, your age, your gender, and so forth. And we are providing you this menu of information. What would you like to do? Would you like to improve this or spend more time on that? So the AI models that give you transparency and choice about what you want to do with them, those are the ones that people who are insiders in this discussion are recommending for you to look for. So then, what can we contribute now? Because we're not powerless. We are part of this process. I think we have to communicate and label the ground or grand truth. And that means we should make our own and keep doing our own documentation of data sets. So this is relevant to data as well as pictures, videos, audio, everything. So please keep taking pictures, taking videos, label them as to what you think based on your expertise, the clinical expertise, is the truth, because these models will need this type of data sets. We should think about the categories, the scoring systems now, and document them well, make them translatable into how other people communicate about clinical states. We should become involved and informed. And I think what is a privilege nowadays is to be allowed to teach ethics and values. This is true for sports. Think about the doping questions. So teaching values in veterinary medicine and agriculture is one of the big privileges that I think that we as veterinarians and agriculturally oriented managers should be involved in. And this is something that is facilitated through the blogs, not so much through emails. Emails are out. Yeah, so that's what my kids keep telling me. We have to be able to text message. We have to be able to deal with the short attention spans of communication today and still convey our message. So I think we have to adapt from any age group into what communication demands from us today, because what is foreseen is that whoever trains for machine learning and artificial intelligence will have to communicate about it to some degree, and not just by providing code. Because only the code is used that is communicated well, that is accessible to everybody and reproducible in terms of results from this code. So just this morning, I added these 3 pieces. One is the press release by Henry Kissinger, and it's amazing how someone who's not a computer-oriented person from his generation, really, how he's able to think about this, how so 3 of his main things are, so the errors that could be committed by an artificial intelligence decision system are sudden and probably more rapidly in their onset compared to errors that were done historically. The errors might have an order of magnitude of consequences that are unthinkable right now. We don't know how they're going to pan out. And he really warns us, don't optimize these models for a single parameter of, I want to kill, I want to win, I want to overcome, but optimize it for multiple parameters. Then there's the second one, is it's by Simon Greenman, who is going to make money in AI. And it shows you a big overview of what he thinks is the truth or the current state of the art with regards which countries are involved in making money and what the developments are, who provides the platforms, who provides the algorithms, and which type of technologies are being influenced by AI today. Really recommendable type of press release. And then the last one is by François Chollet, and he's one of the Google engineers. He's one of the central figures of developing TensorFlow, actually. So if there's someone in the middle of all of this, it's François Chollet. And he wrote a big essay about what worries me about AI, and this is where the statement comes from. It's not AI that is the bad thing. Sometimes we don't need complicated or complex AI mechanisms. A logistic regression will do. It is controlling people using decision-making systems. That's what worries him when it comes to implementation of AI. And I think it's worthwhile your time. And with this, I thank you dearly for your patience in listening to my keynote. And if you are willing to ask some questions, please go ahead. Thank you.